Hello, everyone. I think we're live. Hope we're live.
Yes, we're live.
Okay, it's fantastic. So, hello, everybody. I'm Robin Hunt, and I'm here with my fellow instructors and cohorts in crime to talk about data fundamentals unpacked and languages. I'm glad you're joining us today. Shout out where you're from. We would love to know about everybody joining us. Before we jump into this topic, which we've been having a very fun conversation offline, I'll have everyone introduce themselves. So we'll save our special guest for last. Jenny, tell everybody about you.
Hi, Jenny Von Quarter, based out of Michigan in the Lower Peninsula, and I'm a LinkedIn Learning author for quite a while. Bill.
Hi, I'm Bill Shander. I'm in Boston and also a LinkedIn Learning instructor. I've been coding and doing all kinds of data related things also for a very, very long time. And this is going to be a fun conversation. So, Helen.
I think Robin's next.
Oh,
so
I'm
I already screwed up.
I already did mine. I'm Robin.
Okay.
Yes, I'm the host this time around, and I'm so excited that we have you here joining us, Helen. I think you're going to bring a lot to this conversation. So, yeah, tell everybody about you.
I'm Helen Wall. I live in Houston, and I do teach data science classes for LinkedIn Learning.
Awesome. So I think this is going to be a good episode. I know I was certainly enjoying all of our banter back and forth. I think people are going to be interested to hear all of the different thoughts and opinions and even the commonality we all share in and around languages for data. And of course, when you start talking about languages and coding and data, we're going to definitely talk about software development and things like that. So I'll just jump right in and say we probably really need to define what we mean by coding for the purposes of this conversation. Bill, why don't you give us your definition for coding?
Sure. I have a ridiculously simple definition, which is coding is writing that makes stuff happen in a computer. So, you're writing words and numbers and things too, but you're literally writing stuff. You're not clicking and dragging. You're not, clicking on buttons and filter drop downs and blah, blah, blah. You're not using software. You're just writing and stuff happens. And so, that is a very broad, all encompassing definition. But that's how I think of it.
And Bill, didn't you spend some time early on in your career as a programmer?
Yes, so I've been programming my entire career. So I'll tell you when I started programming. This is going to be a throwback and/or what did he just say for some people, depending on how old you are. So before Adobe, I mean, they coexisted at the same time as Adobe, but there was another company called Macromedia,
Yes.
and they invented a technology called Flash, which was this cool animated thing that we used to make up a lot of websites. But my thing predates Flash. It was called Director. And back in like the early to mid 90s, people made interactive CD-ROMs. You may say, what's a CD-ROM? Even, right? Those little things like this. And so people made interactive experiences out of those. And Macromedia Director was like the leader in the tool for doing that. And it was both a WYSIWYG, click, drag, make stuff happen kind of a tool. But they had a programming language called Lingo. And Lingo was a very powerful, both a scripting language, so it's just sort of very simple if-then statements and things like that, but also you could do object-oriented programming. So fairly advanced, cool, sexy things in Director, including reading in data from external sources, like from CSV files and data-driven interactive CD-ROMs, all kinds of fancy stuff. So I learned to code essentially in Director, if I don't count my one college class in BASIC, which I should not count because I dropped it. Yeah, so I learned in Macromedia Director and then learned web development and then JavaScript and all kinds of stuff. But I've been doing it for a very, very, very long time. I'm pretty bad at it, but I get by.
Awesome. I want to say one thing about Flash, and then I'm going to jump to Jenny and her coding background. I used Flash to animate a Thanksgiving turkey from being a beautiful, alive Thanksgiving turkey to a cooked turkey. And it was very hard to do that. And it made me realize I never want to do this again. It was the great cancellation for my animation life. So when you said Flash, I just immediately saw that cooked turkey. I mean, it was terrible. It wasn't
Flash
good.
of PTSD.
It was hard and it wasn't good and it was never going to be good. And so I knew that was not my career choice, thankfully.
Yeah.
Jeannie, tell everybody about your coding programmer career background, all of the above.
When I was in junior high school, I was teaching basic classes. So, and this is long enough ago, I got to go older than you, Bill, that people actually stored their programs on a cassette tape.
Nice.
That's how long ago it was. So, and I'm not even sure why I was doing that, except they couldn't find actual adults to do that kind of thing. And it's like, oh, yeah, I can figure that out. I'm sure I'll make myself popular this way. Not the case necessarily. And then I've had times that I've worked a lot in coding. I had enough programming classes when I was in college that I didn't have to take a foreign language. They treated computer languages as foreign languages, which then later on when I couldn't speak anything but English, it's like, why did I want that? Why did I think that was a good idea? But when I did programming, probably in the 80s and 90s, it was mostly COBOL, and I became very popular in the late 90s because there was such a shortage of COBOL programmers leading into what everybody perceived would happen in Y2K. So we had a real COBOL renaissance. COBOL is really the first structured language, right? So it's been with us the longest, and it's still with us, which says something about how well it was designed and its durability. And I've taught programming, and I do, the coding I do now is coding I do basically inside of applications more than anything else. So I'm not as involved with, I don't think of myself as much of a coder as I used to be. But I'm grateful for everything I learned as a coder, because that helps you everywhere, even if you're not coding.
Awesome. So Helen, tell us about your coding life.
So I work mostly in data science languages, so SQL, R, Python, and then I also use coding for DAX and M. I've done some JavaScript, just a little, and it's just enough to get by. And so mostly it's focused on more of the problem that I'm trying to solve rather than the code I'm using.
Oh, love it.
There's a lot of different ways to solve things. It's not, you don't have to learn a language in order to solve something. It's just a tool to help solve it. And often it will work faster or be more efficient, less error prone. But it's, at the end of the day, it's a tool. It's a tool in that kit. Rather than, being it's more about the human writing the code and how they're using it than often the semantics of the language. Like, that's important, but it's the person that's writing the code is really driving how that works and what role it plays within a model or just a greater organization.
That's awesome. So I will tell you, and if you've watched any of our episodes before, you've heard me talk about my start. I was the weird person in the corner trying to figure out the best ways to use Excel. And I was in the Macromedia days too. I used to teach HTML, and I would teach people, like, a layer home site was the game-changing software at the time. It would actually close your HTML markup, like you would make a step, whatever. So my exposure to coding was HTML, and we were building client applications back in those days, but that was not anything that anybody was presenting to me. So my exposure to code came through VBA, because I was focused on the Office suite and I had challenges I had to solve, and you couldn't do it natively in the program. I would have to use VBA to extend it. And yeah, it's funny how we all have different introductions into the world that we're in now. So yeah, even though it's not very popular and people like VBA, I mean, I still had to learn procedural coding, still had to define modules, loops, you name it. So interesting. What is the biggest benefit for people, regardless of the language or the outcome? What is the biggest benefit of learning any type of code or language? Who wants to jump in and tackle that?
I would just say quickly, you're no longer constrained by the features and the functionality that whoever wrote your application thought you needed. You can grow your applications faster than and in a more customized fashion than your programming teams can. So it really gives you the ability to leverage what you already know to take it further without having to either perhaps, and picking up VBA as an example, there were so many things you could do in VBA around Excel, for example, that if you didn't do them that way, you had to move to a more structured language, or you had to switch out and move, for example, to SQL Server. So it lets you extend the capabilities of the tool you're already more familiar with.
I love that. Bill, you got any thoughts?
Yeah, I mean, I think that, extending the tool you're in is a huge benefit. I agree with Jenny. On top of that, it just means you can do anything you can imagine. You can, whether you're in a tool or outside of a tool, if I decide I want to make something happen, in a web browser in JavaScript, I mean, I'm not a very good programmer, so I can't figure out anything I can imagine, but someone else has, and I can find their code and copy it, by the way.
Right.
And to that point, if you know how to code, even if you can't execute on anything you can imagine, or you're not going to write your own VBA or write your own DAX, or et cetera, you can copy and paste and tweak and adjust and do things even beyond your own capabilities just by knowing how to read code and just sort of copy and paste and edit it a little bit. It's extending the possibilities pretty massively.
Awesome. Helen, you have any thoughts on the benefits of learning even just a little bit of code?
Well, I think there's it can really, and I add that it extends your own capabilities. And I think that there's also this variety between it kind of extending what you know or learning something new, because depending on what you're already working with, it might just be programming adds, an additional, compartment or additional, capability to what you can do. Whereas sometimes learning something new, it's how does this fit into the rest of it? And, I think that one of the challenges with using code in general is, especially if you're doing it within an organization, is are there other people that can support it? Because there's instances, okay, I've written something in Python, but if there's no one in the organization that can support that, then it's just me, and it's not very scalable. And so it's more about kind of linking up what an organization already does. And often, they may have already paid for their SQL Server or Azure, AWS, whatever they're using. And so it's very hard to swap out of that. Often, those decisions are made, before I come in. And so I'm trying to, what is a solution that works within their organization? Because I don't think you want to be, while the joke is, if you're the one person that can write it, that's job security. I don't know if you necessarily want to be that one person.
No.
Because then you're stuck in that, being that one person. And also, there's a lot, and I see Ginny nodding. So it is just that, how does this fit into the bigger piece of the puzzle? It's not just me and my, what I can do, but how does this fit with what other people can do and what, infrastructure is already built up.
I agree with everything you guys said. I just have one addition to it. I think understanding a little bit and trying to learn a little bit of code also increases your ability to read it.
Yes.
Yeah. And I think as someone who was always the person who got called to fix the problem, this isn't working, could you come fix it? And there would be some kind of coding problem in the background. The little bit of experience I had very early on allowed me to read and understand and break down and troubleshoot. So I think one of the additional benefits to everything you said, like extending capability, is you don't get as intimidated when you have to read it. And I think communicating with other people, like how do you communicate with a coder when everything they seem to do is so different and you don't have any concept of it? So I think reading it and communicating more effectively with your coding teammates, certainly a big benefit.
I think also to that point, by the way, when you learn a language, whatever it is, learning the next language is so much easier. And learning the next language and the next language, it like at some point very quickly you realize it's like if you know French, learning Italian is cake. It's like you're staying within the Romance languages, right? And so it's not like trying to learn Chinese if you learn French, which is a whole different ball game. They're very similar. They follow, like you said before, it's essentially loops and if-then statements and a few other key ideas, and boom, I get it. Now I just got to learn how to put the words together over here instead of over here.
Right.
And I think another benefit to your point about communications is that one of the best benefits is that when someone tells me, whether it's a client or anybody I'm talking to says, oh, we're trying to solve problem X, and they say, is that easier or hard? And I will have an immediate innate sense of whether it's easy or hard, because I know just structurally how code might make that work, even if I don't know exactly how I'm going to write it. I just know, like, making a loop statement spit out a different format of this data set that I have, that's like super easy. Now,
Right.
if I want to transform it 800 different ways and really layer it and do all kinds of crazy things, okay, that might be a little bit more difficult. But knowing how to code allows me to know what things are possible and therefore sort of put a label on how much time it might require.
That is
Or whether you're
awesome.
better off finding a software package that already does it versus writing it yourself.
Right.
So there's one thing that you just brought up that I think this is a good, because you just said it, I'm going to talk about it here. Like we listed out and discussed several different languages, maybe not languages, markup languages, code that makes things, code that edit things, formula languages. So when you mentioned the Romance languages, it immediately made me think about what we were talking about previously, about how you may be coding, but you're coding in something that may or may not be a language. So I'll just start right out the gate. Like I think about HTML, it is a markup language. It marks things up so that it can be read and displayed. And then we were having a very fascinating conversation about one of my favorite letters of the alphabet, M. And is M a language? And are you coding? I definitely think if you're editing the M code that's created from Power Query, you're editing and reading that code. But Helen, I would love to have you share your thoughts on M code and DAX and how do we class those? Are they languages or not languages, and what are they for people?
Well, so I think this is where you get into that debate. So there's an index that keeps track of the popularity of programming languages. It's TIOBE, and it's the TIOB index. And Python has been, climbing up this ranking for a number of years now. And SQL was taken off of the index for several years, and this was probably within the last 20 years, because they looked at the definition for a Turing complete programming language, and so that was something they ended up taking SQL off, and then they ended up putting it back on. And so there are a lot of languages in the index that don't really get used a lot. It's almost like some kind of trying to preserve an old language. But I would say that in terms of the M is a formula language. And the key with that, when I use M, I don't write out a lot of the code. I'll write out part of it, and then I'll use the built-in functions within Power Query to do more of the work, and then I can edit it from there. So it's a combination between coding and then just going through those steps of getting that work and then editing it as I need to. One of the challenges though with M and with any of these is the more customized you get. So M doesn't automatically refresh if you load the model into the Power BI service or a Power BI report server. And so if the code doesn't work, it has to be done another way. So there are limits, and there's constraints for everything. And that's one of the limits. And this is something that is changing all the time. That, I'd have to, check to see what works. But I did run into challenges where I said, okay, well, this isn't working the way that I thought it will be. I guess I'll have to do this another way.
And you end up as a Power Query or Power BI user learning M because Power Query is generating it for you all the time. It's sort of like people who develop databases in Access, right? Could you either learn how to figure out how to use that really archaic query tool that they had, or they could just switch to SQL Server View, right? Model as much as you want and type the rest. And so I really started learning SQL. Well, yeah, probably that's true, or became a better SQL developer because I was using Access as my original model going in. And I feel the same way about M. Like Power BI is generating this stuff. Here it is coming from Power Query. And I can either reverse steps or try different things, or I can learn how to do some basic editing in here to speed up my processes.
So before M and Power Query and Excel, I was writing programming to do all of my data cleaning because I knew I could code to get the data cleaned. And then when Power Query for Excel came about, I no longer needed to do that. But Bill and I share some of the same techniques. We might go into the advanced editor and pull out and replicate some of the M code to create steps so that we're not having to do it through the interface itself. So is it coding if you're editing it like that? I mean, to me, I think it is. I'm sure coders in other languages who are building software client applications might disagree with us, but I don't know. To me, it's coding.
Yeah, but there's a hierarchy of snobbery in coding anyways. Like, C++ coders will tell you that JavaScript is not coding. And JavaScript coders will tell you that, HTML is not coding. So like, yeah, there's always someone you can look down on. But in the end, if I go by my own definition, which I do like, you're writing stuff and you're making it happen. Things are changing. And so no question to me, copying and pasting in M, in advanced editor is definitely coding.
So you just learned to say, Bill Shander says I'm coding, leave me alone.
Yeah. Bill says I'm a coder.
Yeah. But then, the other thing is that, when you think about, this whole idea of what's coding, what's not coding, there is a lot of nuance between these different languages. Does DAX stand on its own? Can I write a program in DAX and make an app on my iPhone? No, I can't. But I can't make an app for my iPhone in Python either, but Python will make an app that runs in the browser, and like all of these different things. But so to me, like the hierarchy is, does it stand on its own and do stuff? And even then, in what different environments, in a browser or on the computer or the wherever, all the way to some things only exist within a software program. Tableau has a whole scripting language inside of it to make very custom visualizations, but it only lives there, just like DAX only lives in Power BI. But it's still coding. You're still writing stuff to make stuff happen. So that's what I think.
So DAX originally came from DAX was originally kind of this SQL Server analysis service was used to write queries. And then so the SQL Server had these separate tables. And SQL Server's been around a while. It's part of, it's an earlier part of programming history, so to speak. And so for years before this, so SQL Server Analysis Services, or Analysis Services for short, came out, I think, 98. And prior to that, with the SQL Server, all the tables aren't connected. So you'd have to write joins in order to connect the tables together and create like a single table output. So the analysis services, and there's people that know a lot more about this history than I do, but the MDX language was what analysis services originally used. And the idea was that the tables were pre-connected. It often takes SQL Server models, connects the tables, and then when you can pull the fields as long as they're connected into a pivot table, for example, and then it will aggregate it. And so the background for DAX kind of started because the tabular models use DAX, and there's people who know a lot more about than I do, but this is my understanding from talking to those people. And then the DAX was in Power Pivot, which I've used Power Pivot enough to not want to use it voluntarily.
You said it out loud.
Oh,
You spoke my feelings into existence out loud. No, I feel the same way as you. I've just never said it out loud.
Well, because I think that the problem is it's not maintained. A lot of it is trying to get it working, and so
yes.
if it crashes, that's a problem. It's not maintained in the same way that it's not maintained in that current suite of programs. So you have to look at what does an organization invest in, how does that fit into the piece. So DAX then so the analysis services, and then Power Pivot, I think, is probably 10 or so years old. And then within Power BI, it actually, every time you update a visual, it runs a DAX query behind the scenes. And you don't even know that. It's selecting part of the data to display in the visual. So every time a filter or a slicer is changed in a visual, it runs a DAX query. And so DAX itself is very specific. I think it is very powerful in Power BI, but it's not, and it's very powerful for creating queries to analysis services. If you're connecting to this analysis services models or other types of queries, but it's not very useful outside of that. But within Power BI, DAX is super powerful and very, very useful.
Yeah,
that's awesome. So, yeah, something we know that other people may not realize is that a lot of coding that you may do is in proprietary language that is exclusively meant for that software or that suite. And frankly, some of it's not translatable to other organizations. Like you may go learn some obscure language in one company and may a master of it, go to another company and they look at you like you have three eyes because they've never even heard of what you're talking about. But if it follows traditional programming fundamentals, you should be able to pick up whatever language comes next. I mean, that's just my opinion. Yeah. Like if you're motivated, you'd have to be motivated to do that.
There's still a really big demand for COBOL, and it's actually talking to colleagues that work in the space for recruitment, and even some people at LinkedIn Learning have mentioned that they've had calls for people looking for COBOL developers. It's something that it may not be what people do all the time, but if there's something that breaks with it, and they estimate with $3 trillion of transactions go through COBOL every day. It supports all the U.S. banking system.
And the insurance system.
And insurance, insurance companies.
So it's insurance and financials. A lot of those folks couldn't update for Y2K. They just simply couldn't. And at the time, one of my friends who was a DBA who'd worked in insurance said, as long as there are insurance and finance companies, we will need COBOL programmers.
I mean, it's people will be like, well, I don't understand. Well, when you have steeped a massive investment into a technology that runs a lot of the information in your organization, like you gotta handle that with care. You don't just go strip it out and go, hey, I want to do this next new pretty thing because it's available now. It's like, no, that's a massive infrastructure that's built and has to be supported. And I know personally too, in our area, if you're a COBOL coder, like you're going to have a lot more success in landing a job in a traditional, older, larger organization because they need that skill and nobody's learning it. It's not the new shiny thing that people are learning. So I think that's interesting.
And yet, if I were somebody who had pretty decent new skills and I had C#, for example, C# is actually a derivative of C, which is a derivative of COBOL. So it's not a big walk backwards to make your way back to COBOL.
How about that?
Just add that to your portfolio. Because Bill said, once you know a languages tend to do the same things, but the languages that are derivatives or stay in families to me, it's like that's easy, because you know everything you have in COBOL exists somewhere in the languages that were derived from COBOL. I also wanted to say one thing back to Power Pivot, our Power Pivot shared moment of, did we say that out loud? Is that I think when you're trying to figure out what you should learn, the fine line between Microsoft or any other company deprecating a product and abandoning it is worth you keeping your eyes on. And one way I look at that is I go look at the roadmaps for those products. And if there isn't one, if there are no new features coming up, that's a pretty good clue to me that the investment in that product is not there. And I shouldn't dive into that. And that's true for the languages associated with those products, the languages that support those products. And I just think it's easy to be the last person to want to learn something that's going to be gone 2 years from now. I mean, in many ways, Power BI has eliminated a lot of the need for Power Pivot, right?
Yeah.
It just has. And you didn't need Power Pivot if you were working with SQL data and your reporting services language, your coding ability there were strong. So it was kind of in a place to be abandoned. I picture like someplace out in Redmond, Washington, you know, Power Pivot sitting on a curb like this, you know, like, right? Nobody loves me. It's
That's hilarious. Power Pivot.
Also, the
A little
interface
cardboard sign.
folder too.
will work for no one.
Well, was Power Pivot the beta for Power BI desktop?
It was one of the betas for it. Yep.
Yeah. Well,
I will say this. I'm sorry, Helen. I will say this about Power Pivot. You could do a distinct count in a Power pivot table where you can't do that with a regular pivot table. I just never understood. Like, I'm with you. Like with the tools we have today that connect to all the same data. If I'm not doing it in a regular pivot table, I'm probably in another tool altogether anyway. I'm sorry, Helen. I just had to throw that out. That distinct count love for Power Pivot, because that's all the love it's going to get here today.
There we go.
Yeah.
Well, somebody in the comments loves it too. So
yeah.
Well, I think that is to go with it. And as Jenny mentioned, looking at the roadmap, look at where they're putting their money and time. Where are other people spending their time? And if they're not spending time there, and COBOL, I mean, because I think that there's also a distinction we kind of want to make here is that in terms of how does it fit into the bigger piece of the puzzle? You know, I mentioned earlier, you know, if I wrote recently, I wrote a Python script to get data, and the idea was that it would get built in other systems. But if it's not something other people can support, then you know, I need to look at how my piece fits into the bigger picture. And I'd say with COBOL has a lot of kind of existing infrastructure, and it's a lot bigger than what we see with existing infrastructure with Power Pivot. Because one of the challenges with Power Pivot that I've found is that it's not stable and it does crash a lot. And that is, you know, that's very hard to work around. And so in terms of, you know, it is, there are trade-offs to everything, and there are constraints. We don't get to kind of go in and pick the language we use oftentimes. This already exists. Oh, that's good. Yeah. So we figure out how to connect to that, you know, connect to this existing, you know, data set or this database. And then what are they trying to do from there? You know, I think there's a lot of projects that have been started, not completed, because someone was trying to kind of build something that didn't connect to other pieces. And if other people support it and find it useful, you get a lot more, you know, a lot more ground to stand on.
Yeah, I think it's important too, because I feel like all of a sudden we're giving Power Pivot just a terrible name. But I think the two interesting things is I think it's important for beginners and entry level, and you're landed in this career to know two things. All software that we see on the front end is running some type of code on the back end. And in the case of Power Pivot, it's using DAX queries, according to what Helen was just telling us. So if you miss that, rewind and listen to her talk about that, because every piece of software I know has got some language running in the background happening. And also, whether you learn this, that, the other, most of the things that we do in and around data are translatable to other tools. So if you're like, I'm a big fan of this software and someone else says they don't like it, don't worry about it. as long as you know what that software is for and what it does, there is probably a competitor out there who you might encounter later that does the exact same thing. It's just the syntax is different and the user interface may be a tad bit different.
Well,
I love that.
look at data scientists and let's start an argument, between Python and R. You get a room full of data scientists together, there'll be a brawl if you start that discussion. And and fair enough. Like, I prefer Python, I prefer R. Fine, like, good. That means you know how to use the tool that you prefer. One is not better than the other. They both do different things slightly differently, and that's okay. That is all translatable, but you may have a preference, and that's definitely okay.
Well, I think what I've seen is that R is actually a bit, for someone that doesn't have a programming background, I think that R is easier to step into and easier to start building, because it has a lot more. Python doesn't have a lot of built-in functions. Most of it is, you've got these reserved keywords, you've got functions that are in the Python and the base package, but there's not actually a lot that you can do necessarily strictly within the base package. You often have to use pandas and NumPy, and then as you build that, you use scikit-learn, and it connects with a lot of pieces. So I think that R has a lot more, and R has packages too, and we can talk about how similar R and Python packages are in a bit, but R, I think there's a lot more built-in functions to use, and so I found that a lot, like, R code will be shorter, and I like the visualization, like ggplot 2 in R looks really nice, and Python you have to kind of do a lot more work to get it looking like that. And there are Plotly, for example, is shared by both of them. So it's not one or the other. I think that I've friends around academia and they use a lot of R. And I know there are a lot of organizations and, well-known and, prominent companies that use R for their teams, but a lot of it is a team endeavor. So you don't typically have, even if people know, both R and Python, if your entire team is using R, then that's the decision. It's not, oh, this person's going to use Python. It's more of this collaborative, like, collective effort. And some of those decisions are made by the people that are currently on the team, and sometimes there's already a decision that's made in the past for that too.
I love that. So as part of our data science and research team, all the researchers that do all the statistical analysis, they're all using R. That's what they use. They like it. So I read a lot of outputs of the data we supply that they've used R to get to. And I think it's important too. I mean, is R dedicated to statistical analysis? Is that where it grew its legs, was for stats analysis
and graphics?
Mm-hmm.
Okay. And so the visualization of it. Mm-hmm. Yeah, because when Python came into the scene of my life, I just didn't understand why we were using a general programming language for data. But I think it's because the size of the data sets. Is it because the size of the data sets make sense to use Python, or is it because programmers are all of a sudden having to deal with more data than they had in the past? I always just get a little bit weirded out about Python in regards to data, since it's a generic programming language. So I would love to hear you guys unpack that.
So
I always assumed that it was the latter.
Okay, so Python's not known for speed. Is that what you said?
Yeah, it's not known for the existing if you use Python, so that you take a data set and you want to run a loop on it, it's really slow in Python. And so that's where you'll see a lot of discussion around the speed of Python, and often using certain functions, using the NumPy package, for example, that speeds it up a lot. And sometimes speed doesn't matter. I think that if you're using a small data set, just on 1,000 rows, it doesn't really matter which language you use, because it's the difference between it is minimal. But for something that's a lot larger, then that's where there are ways, you'll see that if you look up how to make this, Python run faster, there's a lot of discussion around, if you do this, it speeds it up by X, and it's substantial how much it speeds it up, because Python's built on C packages, and so is R. And so C runs faster, but C is a pain to write. And so it's that discussion around like compiled and interpreted languages. And because Python is very elegant in its looks, it is a lot easy to write. Is a very term I'm careful with. But in terms of if you're looking at, say, JavaScript has a lot of colons and curly braces, and it's a lot hard to read, whereas Python is pretty elegant. And so it's less about it's more about, with looking at speed and performance, does this matter? And then if it does, how does this speed it up?
Interesting.
Yeah, I think that's an important point. Like the readability of languages is huge because, JavaScript has all those semicolons and curly braces, and some of the syntax seems a little bit sort of cut off, whereas Python reads like English in a way. It's much more, like an if statement, you get it like the first time you read it. Like there's no shorthand way of doing it. It's very verbose, which is probably part of what makes it slower sometimes. What I personally found challenging with R, as someone who was programming for a long time, was I found it harder to learn because of not so much the readability of it necessarily, as even just things like the way things are labeled. Like, I was used to think about data as arrays, right? Lists of things, objects. That terminology makes sense to my brain. R talks about matrices, right? It's a matrix of numbers, which is the same idea, kind of, but like if it just flips it on its head a little bit. So if you're a programmer, I think Python is easier to learn. If you're not a programmer, to your point, Helen, R might be easier to learn, just to get going on it. And not to mention, it has all the stuff built into it for statistical analysis. So like everything else that we talked about today, there's pros and cons to all these different things. And it really depends on where you're coming from and what you need to do, which gets back to your original point, Helen. You're the human, you're trying to solve a problem, find the right tool, the right language, the right software, the right whatever to solve your problem. And it's going to vary from task to task to task. And this refers back to what you said, Robin, too, which is, before Power Query, I used to write Python scripts to parse data, to gobble that data up and spit it out in a format I needed it into to do whatever I was doing. Now, I always use Power Query. It's so much faster, easier, better, etc. But even now, I still, sometimes it's like a two-step process. I Power Query it to get that base data set in the form I mostly need it in. But then I still might have to write a Python script or something to like rejigger it to put it into like a JSON format that's useful for my JavaScript to work with. So it may be a two-step process, but that first step is like 99% of the time going to be Power Query for me.
So when we talk about what language we should learn, note that Bill just listed 3 in a row to get one thing done. So,
right.
Right. So the idea of what language should I learn probably isn't as relevant right now as it used to be. Right.
Mm-hmm.
What languages are useful to me? And sometimes what drives that is, as Helen pointed out earlier, what languages are relevant to the stack of the company I'm embedded in, or the particular client that I'm working with. I think most of us are at a point where we've had time in our careers that what drove what we learned was what we needed to know yesterday.
Yeah.
Right. And then you get to, and early on when you're, still in school, or if you have time breaks off that you can actually dedicate to learning, right? You can say, what would I like to learn? But some of it will be driven. And I have things that I have learned. I have languages that I've learned that were tool specific that I will never use again. The time I spent learning those, I don't want to call it wasted, because I got paid for the work that I did when I had those languages in my portfolio, but they didn't take me anyplace else. Those are, again, back to sort of those abandoned things. Anything that only works with one tool often will make me pretty suspicious, right? This one piece of proprietary software, because if somebody else buys that company, that's the first thing they're going to strip out. So I tend to try to look at things like how broadly are they used. The other thing is, in terms of Python and R right now, we've had people ask, what's the best language for this industry? What's the best language for this industry? And I'd encourage you to think a little bigger. Do you have data that you need to do something with? That's really the question. because the same languages, if you go ask people in industry, talk to dev folks in industry, the answers are the same. They just happen to think it's specific for their industry, right?
Yeah.
Yeah. And it's surprising sort of the discussion. It's not, oh, this industry uses Python or this industry uses R. It is very there are pockets. It's sort of in a way like, say like election modeling, and that you look at it from the state level or the US level, but really it's much more nuanced. You get down into details by geographical section. You can get very small, you can get into blocks in with a neighborhood, for example. And that's the same way that a lot of those the use of programming languages applies. I will say that there's even DAX, for example, and one of the challenges with DAX is that it doesn't necessarily export easily to other tools. It does really reside in Power BI or bring stuff into to create a data model. But this idea around and this is Excel, for comparison, Excel's very lenient about the data types. So if you put something into Excel and it's a text, it will concatenate. You can put a number on the end of it, and it won't make your throw it won't create havoc. But with any of these programming languages, I think that a lot of the logic stays the same. You mentioned loops and conditional statements, but a lot of it's checking it too, because if you go, you want to make sure the output of what's being produced is correct. And then the other thing is in this idea of a print statement, or checking the type of whatever the object output is. What is this text? Is this text or string, or is it it's a table? And checking that and printing it, looking at what it looks like. It's easy to try to skip steps and say, well, I know what it is because I put it in there. But look, how does the program perceive it? And thinking of it from the perspective of the computer, because we have to specifically tell a computer what to do. And whereas humans, we can say, okay, well, this is the columns because I can see it at the top. But if you've got a white space in one of them, it's not going to recognize the column name.
So I also want to just throw out, just talking about that very thing, not language specific, but just coding in general. It requires a level of patience that sometimes people cannot achieve. Like, your ability to do it could be tempered by your ability to have patience searching for a comma that you cannot see, that's been staring you in the face for the last 30 minutes. And then your friend walks up and says, well, it's that comma right there. So I think it's an endurance game too. You're either into that or you're not into that. And you have to be willing to look for things like that white space that you're not thinking about, but the computer can't translate it. And when you're procedurally programming, you are literally telling it everything it is supposed to do, and you can't fail to tell it what it's supposed to do and then get mad at it when it doesn't do it. And I don't know that people talk about the endurance level or the patience level that you have to have in order to be effective at surviving coding.
Yeah, and
forget learning it, surviving it once you know it.
I mean, that 30 minutes too, if everything took 30 minutes, I would be okay. But there's stuff that takes quite a while to figure out.
Let me tell you something. I can just tell you, as a bad programmer, my entire career I've been a bad programmer. It's my thing. And as a bad programmer, that means I'm a really good debugger, because I'm constantly writing problems. Most of my work is actually finding those problems, and I've gotten really fast at it and really good at it. And so, first of all, that does shrink over time, although I still will be pulling my hair out. I can't really spare that every now and then for something that, should have been easier to see. But yeah, patience is key. It's also, I mean, you kind of alluded to it. You have to actually almost enjoy it. You have to have a little bit of an OCD tendency to really want to go through that. But it's I don't know exactly how to express it. The basic idea is that you are it's as close to pure creation that some people will ever get because
No,
you're writing
yes.
words and then magic things appear over
Yeah.
here. So there's a magic to it, and if you surrender to that, and that includes pain. Yes, debugging is painful sometimes. It also requires. This is going to sound like a very strange word. It requires faith, and especially because, like, I know when I write code, and this is a joke in the coding world, and it's a joke that usually people say to sort of disparage people like me. But I'm going to say, from a positive standpoint, sometimes I will solve a problem, and my code is working, and I don't know why. And that can be a very nervous feeling because you're going to release this thing out into the universe and you're not quite sure why it's working, but it is. And you have to just sort of accept that and allow that to be sometimes. And you have to sort of be able to live in that uncertainty and be okay with that, in addition to fighting through some of those very, very painful moments.
I really love that. I do need to follow that up with one thing I have found. Like, we call them original thought developers. Like, you can bring me something that does not exist, and myself and my team can make it exist. And that is a great, amazing, like you said, the closest thing to creation we can get. I'm 100% for that. But most of the coders in the world are not being allowed to create. They're modifying and maintaining sections of codes in programs that already exist. And so I think that's very important. Like, when you think I need to pursue coding, if you're going to be a creator, then you need to be pursuing opportunities that allow you to create. Otherwise, you're going to land in, like, this is my coding job. Like, I had to throw that out there because I think a lot of times when we're talking purely front end, back end development, there's this idea that you're going to be this fantastic coder and you're going to create this next big thing. And then you show up to work and you monitor these lines of codes all day long. And it's like the greatest disappointment of all time. The other thing is, some of you might just enjoy monitoring the same code over and over and over again because you don't want to create anything from scratch, because there's a lot of pressure that comes with creating something from scratch. I just had to throw that out there.
And I think that folks who are consultants are more likely to be in a place, like the folks who work at Think Data are going to be more likely to be able to do creative stuff. And the reason is that if you go to work embedded in an organization, you join the IT team somewhere, you join an organization that if it's been around any length of time, already has existing code. And 8 out of 10 developers are going to spend their time updating that code and keeping it alive.
Yeah.
And as a matter of fact, I'd even say more than that. In most organizations, when they need them to have something new and exciting, they don't turn to their team of developers because they're busy doing the maintenance that keeps the heart beating. They go hire another organization to come in and do that. I have some real managerial issues with that approach, but that in reality is what happens. So it's like, if you wanted to spend all your time creating, I'm not sure I'd look for a full-time gig in an existing IT department. I'd be tending to look more like for a gig with a consultancy.
Yeah.
Well, even consultancy, I mean, you can come up with an idea and it won't necessarily be implemented. And there are still limitations. Like there are creative aspects to it, but what I saw recently was that, okay, even the Python script works, I know how it works, but who else can work with it? The answer is, that's not the case. Then that I need to look at another solution. I mean, I think that if you want to create things, the best thing is writing apps or teaching courses, right? There's nothing, it's not, you got full kind of ownership or full kind of creative authority with that. But a lot of that is going to sit outside a system because the reality is that technology is a team endeavor. As much as people talk about it not being, don't talk about it that way, at the end of the day, it is really dependent on, who your teammates are, what they know, and being able to make yourself part of that.
So one thing I want to also get in, because I want us to like this conversation, I know we could all force it and talk about this for hours on end, but I think given some good takeaways here. If you're currently inside an organization and you are interested in pursuing further code, I hope you've heard you need to find out the technology stack and the coding that's going down in your organization. Because when you try to figure out what should I learn next, if you're trying to advance within the same organization, you should probably learn their stack. The other thing is, when you go into job interviews and you're truly pursuing your next career choice, like, you can weed out a lot of information for yourself in the interview questions that you ask. What is the stack here? What does the coding look like here for someone who is in this role before me? In your data analysis team, how much coding am I expected to do? And in what languages am I expected to understand and play? You know what I mean? I think that's just some good information, because we want to unpack all of this, but like, what is the key takeaway? Because it's just like anything else. There's tons of languages. They do different things. Some of them build, some of them mark up, some of them just deal formulas. Then there's proprietaries. Like, you can get all over the place really fast, and it makes it super hard for people to know what is their next step to pursue. So, yeah, go ahead.
I would also say in the interview is that the coding stack can be taken from a job description from somewhere else. Like, this could be theoretically what they would like to do. Is I would ask what data infrastructures they already have set up. If they're using, do they have a database that already exists? And if they have a database that already exists, they already have SQL queries that connect to that. Or, do they use analysis services, for security reasons, or, just an organizational approach? Because a lot of organizations may like to think, okay, we're going to skip ahead on the, this data baseline and having everything organized and set up. And they're, a lot of people have come into roles and they thought that the data would already be there, and it wasn't. It was not organized, and so they had to set up a database. They had to set up. They had to become the DBA, which was not something they were expecting. And so I think it helps to ask about specific projects and ask specifically how it's done, because then you can kind of pick apart. Because some of those high-level overviews, they can sort of easily look at, another job description, or have an idea what they're theoretically like to be, several steps down the road, and they're not there yet.
So if you were looking for sort of the general recommendation about what languages are hot right now, you can go to the TIOBE index, and that was already put in the chat earlier.
Yep.
And I mean, Python's hot, right? And so a lot of folks are going to ask for Python. And that's actually a way even to ask, are you keeping your skills up to date? They may not even necessarily want to use it that much, right? But try to figure out what the things are you want to use next, and figure out something to learn next that works for you. Bill, what's the most useful language that you use right now that you've learned in the last however long?
I was going to say, for visualization, because that's where I tend to live, I'm going to add JavaScript to the list very strongly, because while you can also do data wrangling in JavaScript, most people don't, but you can. For visualization, that is the language to know. You're going to be using D3 to generate very custom visual, custom animated interactive visualizations for the browser. Definitely Python for processing data before it gets there. But like I said earlier, I'm going to be using, Power Query before I touch Python, if I do, and the Python less and less frequently these days. But definitely JavaScript. One thing I will add to the list of the benefits of coding, by the way, which I don't think any of us said earlier, is that coding enables you to be lazy, which is what most people who like coding kind of are at their core. I was working on a project recently, and the idea that I had was for visualization. So maybe you're not all doing visualitions like this, and that's fine, but it was like essentially more like a data illustration, more of a very designed custom visual. And I had to create, the idea was to create dandelions, and these dandelions represent organizations and the donations they've gotten from this charitable group. And so I had to create these things with these like hundreds of little seeds coming out of it. And this one has 100, this one has 42, and this one has 76, and they're different measures. And I had to have 1,000 dandelion seeds flying through the air.
Wow.
And so I could have just created these in Adobe Illustrator and then copied and pasted 1,000 times, but man, I'm way too lazy for that.
Yeah.
And I could have made the dandelions by hand and all that, but there's no freaking way. So I use JavaScript to generate the dandelion heads, And then I brought those into Adobe Illustrator, and then I designed it. And same thing with the 1,600 seeds flying through the air. I generated 1,600 seeds in code, and then in Adobe Illustrator just made them spread out randomly and then moved them around a little bit. And
I
so
love that.
I saved myself an insane amount of time because I was able to code it. If I had to make it if I had to make it by scratch, the answer would be I wouldn't. It'd be like pivot tables, like or Power Pivot, like no, thank you.
Yeah.
But yeah, so coding lets you really do stuff that you can avoid doing by hand, which is one of my main motivators.
Major time saver. Major time saver.
Yeah.
All right. Well, we're getting close to the end. I'll throw a shout out for I don't think it ever hurts to learn SQL. I think understanding that SQL is a standard language for querying. I think there's no harm in learning SQL. And then understanding that there's variations of SQL that are proprietary to different software, very important to understand. Also, I had Claudia drop Introduction to Python with Joe Marini in the comments, and then also a shout out to Anise Davis. She has a programming fundamentals course that I think every human being who works in tech should watch, because I don't think there's anything wrong with understanding the fundamentals of programming, even if you're not going to be a coder.
I think it certainly helps you learn even your very first language. I mean, usually you get that as part of learning a language, but the approach where like you go and so many of us aren't even taking a structured approach to how we learn. We're learning by pulling down some examples, copying them and changing them. And if you do that and you've never gotten the idea of what the fundamentals are of how a programming language works, you're really not learning coding. You're just learning copy and paste.
That's right. That's right. Helen, any final thoughts?
No, I would just say it's also a process of what you need to learn for a role and what you enjoy learning. And if you can find something that's useful that you like doing, that's always a good thing.
Absolutely. All right. Well, I think we're coming back sometime in July. Stay tuned on topic. Helen, thank you so much for joining us and having this discussion. I don't think we could have had it as good without you. So we really appreciate you being here with us. And to the rest of you, we'll see you next time.